All right, hi guys. We're going to keep on looking at combining inequalities and looking at where we've got multiple inequalities. And today we're going to specifically look at how you would combine them to show inequalities that satisfy two different equations. All right. First thing we need to start off with, though, is looking at how we would express as an equation some certain inequalities. And the important thing is with this is looking at where we have and or. Okay, because they mean very different things in maths and in English as well. But in maths, sometimes it's harder to pick out, I think. So we've got two different expressions here. We've got x is greater than or equal to 2 and less than 4. And we've got x is less than -1 or greater than 3. And I'm going to show you how you would write both of these. Now, there's a few different ways you can write this first one, but there's only one way we can write the second one. So for the first one, firstly, if we look at the first bit that says x is greater than or equal to 2. Now, you guys should be familiar with this. We're going to look at x is bigger than 2, okay, and less than 4. So we could put a comma and we could say x is less than 4. Okay, we could also write it in words. We could say x is greater than 2 and, sorry, that's greater than or equal to. Sorry, I should have put an equal to there as well. Greater than or equal to 2 and x is less than 4. Okay, or we could write it kind of as you've seen it down below, and this is the best way, is writing the smallest number first. So 2, you've got the less than or equal to x, and then the greater than or equal to x, and then you've got the less than 4. Okay, so that's probably the best way. And that's telling you and, because x is in the middle, and that's between both numbers. So that's saying and both of those. Now, for the second one, there's only one way we can write it, and that is using words. So if x is less than -1, okay, that means that x is less than -1, okay, or x is greater than 3, x is bigger than 3. But there's no way we can put those together because it's an or statement. Okay, it's less than -1 or it's bigger than 3. It's not in between those two. Okay, so if we're looking at this on a number line, this one here, x is greater than 2, and now it's greater than or equal to 2. So we're going to put a coloured in dot at 2 because that shows that it's equal to. We put an open dot at 4 because that shows that it's not equal to. And then x is between those, okay? X is greater than or equal to 2 and it's less than 4. So we're looking at all of those values in between those two numbers, okay? With this one, we're looking at x is less than -1. So again, we've got an open circle because x is less than -1. Okay, that's going down that way. We can put an arrow to show that it keeps going. Okay, or x is greater than 3. So again, we put an open circle at 3. We're going in that direction, okay? So x is bigger than 3 and it's less, or it's less than -1. It's not and less than -1, so it's not in between those, okay? So hopefully you can see the difference between those. If we did it the other way around and we said x is less than or equal to 2, or x is greater than 4, okay, we can see that this is going to look different. That would be less than or equal to 2, so it would be going down in this direction, okay, and it's equal to, so that would be coloured in. Or x is greater than 4, so it would be from 4 and going bigger, okay, so we'd be not including that same interval that we did before. So these are kind of how you think of it, almost the opposite of each other, okay, the and or. All right, now this is going to come into play for where we're looking at combining different inequalities of different equations. So I wanted to give you a little bit of a context to start off with this first, okay? So your context is, now this was true at the start of lockdown. It's now no longer true because I hurt my knee. But to keep fit in ISO, Miss Hoadley runs for more than 45 minutes per day. Her husband, on the other hand, hates running, so he only runs for between 20 and 60 minutes per day. What could be an inequality to show the amount of running they do as a household? Now, I'm going to use x as my variable, okay, and that's going to be the amount of running. So in this case, I run for more than 45 minutes a day, so x is greater than 45, that's for me. Now, for my husband, he runs for between 60 and 20 minutes. So in this case, his amount of running would be less than or equal to 20, and greater than or equal to 20 and less than or equal to 60. Okay, so if we were going to put this on a number line, or if we were going to show it, let's say 45 is here. Okay, here's me, I'm running for more than 45. Okay, my husband, he's running for between 20 and 60. Okay, there's his values there. Okay, you can see between 20 and 60. Now, if we were trying to represent these together, we're only looking at the parts where we have an overlap. Okay, so where we're overlapping our inequalities, okay, which is just this little bit here, that's going to be our solution. Okay, so only where there's overlap, and that's really important for what we're going to get to. Okay, so now that 45, that's included in his. Okay, so we're going to use, now we're going to use a closed circle for 45 because he is running for 45 minutes, potentially. Okay, although probably not. And that 60 is also included. Okay, so if we put them together, this is just this little bit that's in between. I'll just draw it in here. Okay, so that's 45 and that's 60. So now if we're going to write it together, we would have x is greater than or equal to 45 and less than or equal to 60. Okay, and that would be our combined inequality, which is just that overlapping region. Okay, so we'll look at a couple more mathy examples. So in this case, we've got x is less than 2 or x is greater than 5, and x is greater than 4. So there are two equations. Now again, if we're going to combine those together, we only want to look at the bits where we overlap. So where we're overlapping is only from 5 and bigger. Okay, so we can get rid of this 2 part, right? We can get rid of this 4 part. Okay, we're only looking, and this stays as an open circle in this case because this is because you always take like the smallest possible values. Okay, so in this case, not necessarily, in fact, and I think that means actually that I did this wrong here because that should probably be an open circle. Sorry, that's my bad. That should be an open circle 45 because I'm running for more than 45 minutes, so I'm not including that 45. So the only part where we overlap would be more than 45. Yeah, that makes more sense. Okay, cool. So we're only looking at greater than 5, so we have an open circle and that 5, and this is our overlapping part here. Okay, so our only solution when we join those together is that x would be greater than 5 because that's the bit that's in both parts. Okay, if we look at the next one, okay, we've got x is between 2 and 5. Okay, so it's x is 2, x is greater than 2, and it's less than 5. In this case, x is less than 4. So when we're looking at our overlapping part, okay, this 5 isn't included. Okay, this bit that's less than 2, that's not included. Okay, so we're only looking at this part here. So again, we've got open circle from 2, open circle from 4. Okay, so x would be greater than 2 and less than 4. Okay. So if we go on to, this might be a type of example that you might get in, say, a test or something. So what values of x satisfy both equations? So I want you to do it like a number line. So we'll write it out first. So this first one, this is x is greater than -1 or equal to. Okay, so we've got -1. We're going to put our equal to sign there. And it's less than 5. So if we just put arbitrarily a 5 up here, put an open circle, okay, we're looking at, this is our first inequality here. I might just change the color. Okay, for our second one, we've then got x is less than or equal to -3. Okay, so -3 is all the way down here. Again, put a closed circle, so less than or equal to -3. Okay, or it's greater than or equal to +3. So I'm going to put that's +3 there. We might be bigger than or equal to +3. Okay. Now, again, we've got the next thing is we've got to look at where do these overlap? Where are our overlapping regions? Well, we can see that that -3, that doesn't overlap at all. Okay, this doesn't overlap until you get up to this bit where you've got +3 here. And then we've got this overlapping region up until 5. So from here, okay, 3 is included in both, so we can use a closed circle for 3. But 5 is not included in both because it's not included in the top one. So we have to use an open circle for 5. We're looking at all the numbers between there. That's 3, that's 5. Okay, so our solution is that x is greater than or equal to 3, okay, but less than 5. All right, again, you've got another little worksheet to do for this afternoon. Hopefully this will make sense. Again, contact me with it if it's not, and then we can have a chat about it, okay? I look forward to talking to you on Thursday. Have a great afternoon, and that's it for today. Okay, bye.